Good day. Here we are to solve a linear programming minimization problem using the five-step method, or we are to solve this using the graphical and corner point solution method. So we will read. The Summerfield Mill Turkey Ranch is considering buying two different brands of turkey feed and blending them to provide a good low-cost diet for its turkeys. Each feed contains, in varying proportions, some of all of the three nutritional ingredients essential for fattening turkeys. Each pound of brand 1 purchased, for example, contains 5 ounces of ingredient A, 4 ounces of ingredient B, and zero point 0.5 ounce of ingredient C. Each pound of brand 2 contains 10 ounces of ingredient A, 3 ounces of ingredient B, but no ingredient C. The brand 1 feed cost the ranch 2 cents a pound, while the brand 2 feed costs 3 cents a pound. The owner of the ranch would like to use linear programming to determine the lowest cost diet that meets the minimum monthly intake requirement for each nutritional ingredient. Minimum monthly requirement per turkey for ingredient A, B, and C are 90, 48, and 1.5 ounces respectively. Ngayon, we let uh, we let our x be the number of pounds of brand 1 feed purchased, and we let our y as the number of pounds of brand 2 feed purchased. For the step 1, we will develop the table. For our column info, we will have the brand 1 and brand 2. This in composition of each pound of feed per ounce. And then a column for design and its right hand side values. In our constraint are the ingredients. We have ingredients A, we have ingredients A, A, and we have B and C. Okay, and the last row will be our objective. If you read earlier, our objective is to find the minimum or the lowest cost. So let's fill this table up. When we read this, each pound of brand 1, no? So our brand 1 purchase, for example, contains 5 ounces of ingredient A, 4 ounces of ingredient B, and zero point 0.5 ounce of ingredient C. Okay. Each pound of brand 2 contains 10 ounces of ingredient A, 3 ounces of ingredient B, but no ingredient C. Okay, the minimum monthly requirement per turkey for ingredient A. So when we say minimum monthly requirement, so it should be, the sign will be greater than or equal. For A is 90 ounces. For ingredient B, it's 48 ounces. And for ingredient C, it's 1.5 ounces. And then we can see here that brand 1 feed costs the ranch 2 cents per pound. We put here 2. While brand 2 feed costs 3 cents per pound. Okay. Now for the second step, our linear programming model, we will just copy the info from the table. Objective function is min C is equals to 2x plus 3y subject to the following constraint. For ingredient A, for ingredient B, and for ingredient C. And then our non-negativity will be x and y should be greater than or equal to 0. Okay, next step is to graph. Now we will solve this by graphical and getting the corner points or the vertices. Okay, let this be equation 1, this as equation 2, and this as equation 3. For equation 1, we substitute x if 0, we get y as 9. If y is 0, we get x as 18. So for our first line, we have y 9 and x 18. Okay. For the second constraint, we substitute x is 0, therefore y is 16. If y is 0, x is 12. So we have y 16 and x as 12. Okay. X therefore is equals to 3. So where is 3? Here is 3. Okay. Now, for the shading, since all of them are greater than or equal, the shading is upwards, so we shade upwards. And then for the second constraint, upwards. And for the third constraint, or the third line, since this is in greater than or equal, we shade to the right. Now we will get the corner points. So this is a corner point. Then we have another one. This is a corner point. And this one is a corner point. So this shaded region is also called the feasible region, where the optimal or the initial optimal solution is found. Okay, so we will get in which vertices is the answer. Okay, for step 4, we get the vertices of the corners. Okay, the first vertex is here. We have this is 3, this one is 3 and 2, or sorry, 3 and 12. We substitute 3 and 12 to the objective function. We will get 42 cents per turkey. In this vertex, that is 8.4 and 4.8. We substitute the values to our objective function. We get 31.2 cents per turkey. And our last vertex, which is here, that is 18 and 0. We have 2 times 18, and this is 0. We have 36 cents per turkey. Now, since we are getting the minimum cost, we will get the minimum value among the answers. And that is this one. Finally, for our initial optimal solution, hence the minimum cost solution is to purchase 8.4 pounds of brand 1 feed and 4.8 pounds of brand 2 feed per turkey per month. This will yield a minimum cost of 31.2 cents per turkey. Thank you very much and have a good day.